Welcome everyone. In this video I want to look at the idea of reactions happening from solutions, meaning you mix two different solutions, or at least meaning you have something in solution in one beaker, something else in solution in another beaker. You mix those two beakers, resulting in a bigger solution, some reaction happening in the middle, and that leading to changes in concentration, species perhaps precipitating out, new species forming, that kind of thing. Right. And of course, all the ideas of limiting reagents and so forth come to the fore again. Okay, so in this example, we're told 150 milliliter of a copper nitrate solution is allowed to react with a 200 milliliter for 0.5 molar sodium carbonate solution. Answer the following questions for the given scenario. So it's all determine the concentration of all the species after the reaction is completed. So our first step is to determine what the reaction equation is. So what happens here? Well, if you think about it, we're basically taking two aqueous solutions, right? That's what we're told. We're taking two solutions. So it is a copper, one is copper nitrate, 3,2 aqueous, and we're adding sodium carbonate, a solution of sodium carbonate, to that. Right, and these are exchange reactions, or this is an exchange reaction, that is what will occur. So we can write the product that, or the products that will form is going to be copper carbonate and sodium nitrate. And we can just quickly balance that. There will be 2 sodium nitrate that forms. And to check the phases, so all nitrates are soluble, but copper carbonate is insoluble. So that forms a precipitate. So that means that anything that goes to copper carbonate is no longer soluble. It falls out of solution. So drawing it in picture terms, or pictorially, we have a situation as follows. Okay. We have our initial copper nitrate solution. It is 150 milliliter, 1 molar. So it's 150.0 milliliter, 1.0 molar. Right, here are copper 2 plus ions, and we have nitrate minus ions. There will be twice as many nitrate ions as there are copper 2 plus ions. Here we have carbonate, so we'll have CO3 2 minus, and you'll have sodium 2 plus. We'll have sodium plus ions, and how much of this? 200 milliliter of a 0.5 molar solution. Okay, so that's what we have. That then leads, we mix those two things, that then causes a precipitate to form. In other words, a solid to fall out of solution, lying at the bottom, which is the copper carbonate. Okay. So in principle, if we mix 1 mole and 1 mole of these two things, then all of the copper and all of the carbonate would go to the solid phase and no longer be in solution. And all that is left here is the sodium and the nitrate. But the question is there perhaps something in excess? Is there perhaps something limiting? Because that is the case where everything is reacted in a stoichiometric ratio. If we don't react it in a stoichiometric ratio and something is in excess, then perhaps there could be additional ions. So we can ask, is there other ions still present? So any other ions still present, Right. The only way we can do that is we must determine in our first step what are the number of moles of the copper nitrate and the number of moles of the sodium carbonate. Of course, it's the volume of the solution multiplied by the concentration, volume of the solution multiplied by the concentration. Should get here 0.150 mole. You get 0.100 mole. Right, and if you see, they need to react in a 1-to-1 ratio, meaning that those two numbers should be equal for them to react in a perfectly stoichiometric ratio, and clearly those two numbers are not. The copper nitrate number is larger. Hence, we know that the sodium carbonate is limiting. And you should be able to quickly deduce that 0.050 mole copper nitrate NO32 is in excess. Right, because 0.1 mole of the copper nitrate reacted with 0.1 mole of the sodium carbonate to form 0.1 mole copper carbonate precipitate, those red dots. Right, that's what fell out of solution. So we can then go, so we've deduced that. So now we know it's limiting and we know what is in excess. We're told determine the concentration of species that are present after reaction. So things that are present, we said sodium and nitrate will be present after reacting. So we can know that the number of moles of the sodium and sodium nitrate is going to be twice that of the number of moles of copper nitrate. Right? Not copper nitrate. It's the sodium nitrate that forms is going to come from the sodium carbonate, right? Because it's limiting. So in other words, 0.200 mole sodium nitrate forms. Okay, you can see it's a 1-to-2 ratio. All right, so we know that's how much sodium nitrate NO3 forms. Question, how much nitrate is in excess? So that's reacting. Things that are in excess, so that means there is still copper nitrate left, and that we said is 0.05 mole. Okay, so that gives us copper nitrate. So this gives us a summary of what are the moles of the stuff that is still in solution, because the sodium carbonate gives us an idea of how much copper carbonate formed, and this gives us an idea now of how many moles of ions are still left. So how many sodium nitrate formed and how much copper nitrate was left in excess. Okay, so from this top here, we can create a little summative sketch, or whatever you want to call it, it means the number of moles of copper 2 plus is, we get 0.05 mole, 0.0250 mole of copper 2 plus, right? The only source of copper 2 plus is the excess amount of copper nitrate. So there's only 0.05 mole copper 2 plus. We have an excess, well, not an excess amount of sodium, but all the sodium went to the sodium nitrate, and it is 0.200 mole sodium plus, right, from the sodium nitrate. Now comes the interesting one. We have two sources of nitrate. Nitrate, firstly, comes from sodium nitrate. There was 0.200 mole that was formed, but there was also 0.050 mole in excess left after the reaction. So that gives us 0.250 mole. .02, actually no, this is 2 times this. So let me just retrace that. How many moles are in excess? There's a 2 there. So if there is 0.05 mole copper nitrate in excess, it means there is 0.100 mole nitrate in excess. So let's make this 0.300 mole nitrate in excess. Well, 0.1 mole in excess, 0.2 in cahoots with the sodium. All right, so those are the 3 things that we have. So let's quickly just revise, because I made a little boo-boo, so I know that sometimes throws you off. So what happens? We have a reaction. We then see, okay, right, anything that goes to copper carbonate isn't soluble. All the sodium nitrate is soluble. So then we calculate how much sodium nitrate forms. The sodium nitrate is twice that comes from the sodium carbonate. So we determine how many moles of sodium nitrate forms. We determine that 0.2 mole. Then we ask ourselves, okay, but how much reagent is left? Of the excess one, there's 0.05 mole copper nitrate left. Okay, and then we want to determine how many of each of these contribute the ions. So from sodium nitrate, we get 1 sodium ion and 1 nitrate anion. From copper nitrate, we get 1 copper 2 plus ion and 2 nitrate anions. In other words, it means if we have 0.05 mole of copper nitrate, it means there will be twice that amount of nitrates present from that amount. So in other words, 0.1 mole. And then we just sum those amounts. So copper, the only place is the excess amount. And sodium, the only place is the sodium nitrate. But the nitrates come from the excess plus the sodium nitrate that's formed. Okay, and hence it is 0.03. And once we have that, then we can start calculating their concentrations. So our first step to calculate the concentration is we now need what is the final concentration or the final volume of our solution. Our final volume is, of course, the sum of those 2 volumes. So we have a final volume of 350 milliliter. Right, 350 milliliter. Okay, so we can calculate each of these concentrations. So that means the concentration of copper 2 plus is equal to, where's copper 2 plus? So it's equal to the 0.050 mole divided by the 350.0 times 10 to the power negative 3 liter, and gives you a value of 0.143 molar. And of course, each of these is divided by the same volume. So it's just the value here divided by that concentration. So the concentration for the sodium is equal to 0.571 molar. And the concentration of the nitrate is equal to 0.857 molar. Okay, so what are the important things to remember? Remember, the volume is the final volume is now the sum of the two volumes that you mixed. Where are everything going? You have a source of ions from the excess reagent, as well as the thing that is still in solution at the end. So you do it like a normal reaction. The thing in the end has a number of moles coming from the limiting reagent, giving you a certain number of moles. The thing in excess produces a certain number of moles, and then you check your ions, and you just calculate their concentrations. Okay, so now at least the A part done. Now we're told, suppose 11.87 gram of carbonate precipitate is obtained in the reaction described. What is the percentage yield of the reaction? Okay, so now we're told something about this carbonate. We're told, suppose we get 11.87 gram of this. What does this tell us? So what would we have expected to get given this? What would the mass of the copper carbonate have been given this information that we had here? All right, so let's go this way. So 11.87 gram of copper carbonate, you can go and calculate, gives you a certain number of moles of copper carbonate, right? And you can just go and check what that is so that you can use it later on in the equation. What we needed to check, I just actually need to find myself a calculator quickly. Okay, I'm back. Thank you. Thank you for your patience. What we wanted to know is the theoretical mass. The theoretical mass of 0.1 mole of copper carbonate. Right. Of copper carbonate. You don't need to do that. I don't know why I just wrote that down. Of copper carbonate. The theoretical mass of copper carbonate. So that would be M copper carbonate, meaning what we would expect to get is 123.55 gram per mole multiplied by 0.1 mole gives us an expected mass of copper carbonate of 12.355 gram, and so forth, gram. Copper carbonate is what we expected if we go up top here. So the 0.1 mole of sodium carbonate produces 0.1 mole of copper carbonate because it's a one-to-one reaction. So the theoretical mass of 0.1 mole copper carbonate is that. So then the percentage yield is equal, of course, to the actual divided by the theoretical, there needs to be an H there, multiply by 100%. So this is the 11.87 gram divided by the 12.355 gram multiplied by 100% gives you 96.17%. Okay, very close, but not exactly 100% yield. All right, so let's move on to question C. Suppose the solid sodium carbonate used to make the solution was only 92.3% pure. What mass of the solid would have been weighed out to give 12.36 gram of copper carbonate precipitate? All right, so let's work kind of backwards here. 12.36 gram copper carbonate implies that we want a number of moles of copper carbonate of 0.10004 and so forth mole. All right, which implies we want the same number of sodium carbonate moles. Okay, and once we have that, then we know what the mass of that sodium is that we need. And of course, once we know what that mass is, we just inverse multiply to upscale that. So we know that this mass is then we need 10.6031 gram sodium carbonate. But that is if the sample were 100% pure. So therefore, this the mass of this sample is equal to just 10.6031 gram multiplied by 100 over 92.3 gives you 11.45 gram. Because essentially what it says at the end of the day, what mass of solid would have to be weighed out to give 12.36 gram of copper carbonate? So what we did is we determined what would give 100%, and we just worked backwards. So how many moles sodium carbonate did we need? That gave us the mass of sodium carbonate we needed, but we know the sample is not exactly 100% pure. So the question you ask is what value needs to be multiplied by 92.3, is it 92.6? No, 92.3. 92.3 over 100 to give, so which value needs to be multiplied by 100? 92.3 over 100 to give 10.6. That's essentially what you're trying to get to. So normally what you would have done is you would have said, well, we have a sample that is so much pure. You take so much of a sample that is so much pure, and that would give you that much, and then you would work forward. Now you just start at the back and you worked backwards. So yeah, don't let the percentages fool you. I think the percentage yield and the percentage sample purity is easier to gather, but the difficult part comes in here, in the where the precipitate forms. But I think that sort of is sorted out now. All right. Thank you for watching, and I'll see you in the next video.